Lesson 1.7 is constant rate of change. A rate of change is a rate that describes how one quantity changes in relation to another. In a linear relationship, the rate of change between any two quantities is the same. A linear relationship has a constant rate of change. So basically what that's saying is that in a line, like when you look at a graph and you have a line on it, it is going up at the same rate, which is that constant rate of change. Number 1, the table shows the amount of money a booster club makes washing cars for a fundraiser. Use the information to find the constant rate of change in dollars per car. So if they want dollars for every one car, we do dollars on top and car on bottom. So 40 divided by the number of cars, so they made $40 by doing 5 cars, so that was $8 per car. 80 divided by 10, again $8 per car. 120 divided by 15, again $8 per car. And 160 divided by 20, again $8 per car. So we say $8 per car, and that is the constant rate of change. So every time it is changing by $8 per car. Okay, number 2, the table shows the number of miles a plane traveled while in flight. Use the information to find the approximate constant rate of change in miles per minute. So as you can see, we're going to take miles over minute. So we're going to take miles divided by minute to find how much per minute. So 290 divided by 30 minutes is going to get us 9.6 repeating. 580 divided by 60 is again 9.6 repeating. 870 divided by 90 is again 9.6 repeating. And 1,160 divided by 120, you guessed it, 9.6 repeating. So that is 9.6 repeating miles per minute. And yes, you have to write that label out. I know it's going to kill you. It's going to be so much work, but that's the big thing about this chapter is those labels so that I know that you understand what the question is asking. Okay, number 3, the graph represents the distance traveled while driving on a highway. Find the constant rate of change. So the constant rate of change, we want to know how much is this changing every hour. And if we look at the first hour and what's the rate of change there, it's 60 miles per hour. So if we go to 2, there they've reached 120. So again, it's changing by 60 miles per hour. So we say 60 miles per hour. On accelerated math, I have a lot of, in this one we could have done MPH. On accelerated math, a lot of times I have kids really struggle with this objective because it's almost too easy, you just look at where's the 1 and then you go up to the y value and it's 60. And so then that's your answer. Number 4, explain what the 0.00 and 160 represent. So this is the same graph as our graph in the last problem. Our 0, is where the car starts driving. They haven't even started driving yet. So 0 is where car is just starting to drive. And then 160 is you're going to use your label. So you're going to say the car's been driving for 1 hour, and you know that based on the label. And in that time frame, they've gone 60 miles. So car was driving for 1 hour. And they traveled 60 miles. Number 5, the table and graph below show the hourly charge to rent a bicycle at 2 different stores. Which store charges more per bicycle? Explain. So if we're trying to find per bicycle, well, it really would be per hour, not per bicycle, because this is showing that it's $24 for 1 hour, and then this one is or $24 for 2 hours, and then this one shows $16 for 2 hours. So we take 24 divided by 2, and we get this one is $12 per hour. And we come over here and we look at how much does this one charge for 1 hour, and it is $8 per hour. So which one charges more per hour? That would be Petals Rental. I circle it, and that's my answer.